we will see shear force diagram and bending moment diagram of this beam. Total length of this beam is 7 plus 1 8 plus 2 10 meter. Total length is 10 meter and 180 Newton per meter load is acting on this beam throughout. C unit Newton, and at point A there is 200 Newton downward load, and at point B and C there is vertical reaction, and we need to calculate shear force diagram and bending moment diagram. Our solving methodology is, first we judge this and then after we will find values, numeric values, and then on StatPro software we will check it. So see, as per my judgment, 180 Newton per meter is throughout load. This 200 Newton is near to this B. That means this B is maximum because more load is toward this point B. This is now calculate SFD. This 200 Newton is downward. That's why this is downward. Between A to B there is UDL. So inclined line. This B is maximum. That's why this goes upward. Straight line, straight. And B to C, it is inclined. This goes upward. This C is also goes upward. And between C to D there is also incline because of UDL. This is B. So this is negative, positive, negative, positive. SFD, judgmental SFD. Now next calculate bending moment diagram. Before that, see this beam deflect like this. So this is hogging and this is sagging. So see this. For that portion, hogging movement generates. At cantilever A end, there is zero movement. So this is like this. See here, shear zero. That means movement maximum. Again it drops down, and again hogging like this. This is positive, negative, negative. Now next calculate reactions. Vertical positive, downward negative reactions. So let's consider this as By and this as Cy. So positive By plus positive Cy, and this 180 Newton per meter is acting on 180 Newton per meter is UDL. Convert this UDL into point load. How to convert UDL into point load? This total UDL multiplied by total distance on which it is acting. So it is 180 multiplied by 7. 180 multiplied by 7, it is 1260 Newton, and act at center of this total length beam. So that means this is 5 meter from A and 5 meter from D. So minus 1260 minus 200, because see this 200 is also downward. So by plus cy minus 1260 minus 200. So by plus cy is equal to 1460 Newton. Now calculate dy or cy. So I am interested in calculation of interested in take moment at this B. So see this 1260 is clockwise to this point. This cy is anti-clockwise, and this 200 Newton is also anti-clockwise. So clockwise positive, anti-clockwise negative. Twelve sixty is clockwise, and into from A it is 5, but from B it is 4 meters. So 1260 into 4. Again cy is upward, so it is clockwise to that point. So minus cy into 7. Minus anti-clockwise, cy force 7 in lever arm, and this 200 is also anti-clockwise, and distance is 2 meter to that point. So minus 200 into, sorry, distance is 1 meter, minus 200 into 1 equal to 0. So this force, this, okay. So this cy is equal to see here we make mistake. Total, see this, why it is 7. It is not only 7, it is total 10 meter. So 180 into 10 is 1800. So here it is. So cy is plus 800 into 7 minus cy into 7 minus 200 into 1 equal to 0. It is 200 into 1, cy into 7 into 4. So it is CY is 1000 Newton. Yes, it is correct. Now here it is also 1800. If reaction wrong, then SFD wrong, then BMD wrong. Take care of while calculation of reactions. So put this CY in this equation 1. BY is equal to 1000 Newton. See, this BY is 1000 Newton, this CY is also 1000 Newton, and total upward load is also 800, 200. Total upward load is 2000 and total downward reactions are also 2000. That's why every action there is equal and opposite reaction. So next calculate shear force diagram. Shear force at point A equal to 200 Newton minus 200 because this load 200 is downward. Shear force at point B. See this point B and see left side of this point B. How many forces left side of this point B? Two forces. One is 200 Newton and another is 180 Newton per meter acting at this 1 meter distance. So shear force at point B, and not only at point B, just left to that point B. Shear force point B just left to that. One load is minus 200, another load is minus because of downward. Another load is 180 Newton meter. 180 is also downward, that's why 180 into 1 into 180 into 1 is conversion of UDL into point load and acts on 1 by 2 distance. See, no, 1 by 2 distance, don't multiply this 1 by 2 distance because this is moment. We are only interested now in shear. So, see, remember sign conventions properly. In shear, we only consider downward as negative, upward as positive. So this sign conventions remember. So this is minus 380. Unit is Newton because load is in Newton. So this is minus 200. Unit here Newton, SFD unit. And this is minus 380. Now see, bending moment just left to that point B. See this BY reaction is at point B. So due to this BY reaction, this minus 380 and this BY reaction is upward, so plus BY, minus 380 plus BY, and BY is 1000, so minus 380 plus 1000. Shear force at point B, just write to that minus 380 plus 1000 equal to 620 Newton. Now see next point. Next point is this C point. So this C point is calculate shear force just left to that C point. For calculation of shear force just left to that C point, see loads, left side loads. Left side is, these are all loads, left side, see, these are all loads. But now currently we calculate shear force at point B, and right side of that point B is 620 Newton. So we calculate shear force here. So take this shear force and this load. So this shear force is, see this 620 Newton and minus 1800 Newton UDL. So it is 620 minus 1800, it is minus 1180 Newton. I think this is 180 into 7, only consider 7 here, because see, this 10 is for total beam length, but we are considering this load also, so don't take this 10, only consider 7. So 180 into 7, minus 180 into 7, 620 minus 180 into 7. So this is minus 640 Newton. Now shear force just right to that point C. Just right to that point C. This CY reaction is positive 1000. So minus 640 plus 1000. So it is 360 Newton positive. Here it is 360. Here minus 640. Point B, right, 620. Now see, this D is cantilever end, so at point D it is 0. So calculate just left to that point D, because of C, UDL is acting on this. So up to here shear is 360. 360 minus 180 into 2. So it is 0. Yes. That means our SFD is correct. See our judgmental reaction maximum 1 kilo. You see, my maximum judgment is wrong here. This is not maximum shear here and reaction here. Reactions are same. So see why this Cy is maximum. Understand this. See this portion. Length is maximum 2 meter and load is 180. So 180 into 2, it is 360 load acting on this 2 meter distance, and here this 200 and 180 into 1, 380 load is slightly maximum, but this seed is distance, this 1 meter is very minimum, so that's why the judgment is wrong. So shear is maximum here. See this 640, only see values. Now next is calculation of bending moment. At point A, bending moment is 0, and at point D, bending moment is 0, because both are cantilever end. Bending moment at point A is 0, and bending moment at point D is 0. Now calculate bending moment at point B. So this 200 Newton is anti-clockwise that to that point B. That's why minus 200 into distance is 1, and this UDL is also downward and anti-clockwise. So sorry, anti-clockwise. Minus 180 into 1 into 1 by 2. 180 into 1 into 1 by 2. It is minus 290. So this is 290. Bending moment at B is equal to 219. Unit is Newton meter because loads are in Newton. Now calculate bending moment at this point C. See this load here. 180 is clockwise to this from right to left. Change sign of calculated bending moment. So this is clockwise 180 into 1 and into 1 by 2. So it is 90 positive, but change sign while calculation of right to left. So minus 90. No, just this is 2, 180 into 2, 360 minus 2 by 2. 180 into 2 into 2 by 2 is 1. So this is 360, sorry. Because this distance is not 1, this distance is 2. 360. See how distance change bending moment. If you take here 1, then bending moment is directly 90. But if you take 2, then bending moment is 360. Increases 4 times. If you increase length as a double, then moment increase as a 4 times. So remember this, if you increase length as double, if you increase this 2 to 4, then this 362 directly 4, 360 into 4, this is 1400. So this is thumb rule. Now calculate maximum bending moment here at this point where shear is 0. So what is this distance? So for that calculate this x. Calculate this x. First consider this beam 200 B and UDL 180 Newton per meter. So this is EMX, this is VX. So let's take shear is equal to 0 here, minus 200, positive 1000, By is 1000 Newton, minus, this distance is x, 200x minus Vx. So 800 is equal to 200x. So x is equal to 4 meter. So this x is 4 meter. So calculate bending moment at 4 meter. So this minus mx. Calculate bending moment here. Minus mx minus 200 into 4 into 4 by 2 minus this UDL 200 into 4 into 4 by 2 minus 200 into 4 plus B 1000 into 3 because this is 1 meter. So minus mx, so mx is equal to is 200 into 4 anti-clockwise minus 200 into 4 into 4 by 2 minus plus 100 into 3 minus 200 into 4 minus 200 into 4 into 2 minus 200 plus 1000 minus 200x 800 See, we know this distance. This distance is 1 meter. but we don't know only this distance. What is this x from B? So solve it by that way. So shear shear calculation takes shear at this Vx is equal to 0. So minus 200 minus 200 into 1 minus 200 into x by 2 and plus by is 1000 equal to 0. So this x is equal to, see again why we consider this x by 2. This is not x by 2. So solve it by that way. 200 minus 200 minus 200 into x plus 1000 equal to 0. So it is 3 meter. See, this is not 200, this is 180 Newton per meter. That's why our calculation is going wrong. Minus 200 minus 180 into 1 minus 180 into x and plus 1000 equal to 0. So it is 3.44. So now it is correct. So from A point it is 1 plus 3.44. That means 4.44 meter distance, bending moment is 0 from A. So 4.44. Now calculate moment. This is 3.44. Calculate moment at this point. So minus mx positive this 200 into 4.44. This 180, take total 180 minus 180 into 4.44. This 200 is also minus because it makes anti-clockwise. So this x is 3.44. So calculate moment at this point. So minus mx, this 200 is anti-clockwise, minus 200 into 4.44. 1 plus 3.44 is 4.44. This 180 minus 180 into 4.44. So this is point load and multiply by 4.44 by 2. And again this by is clockwise, so by is 1000. 1000 into 3.44 equal to 0. So minus mx minus 200 into 4.44 minus 4.44 by 2 and positive. So mx is equal to minus 200 into 4.44 minus 180 into 4.44 into 4.44 by 2, positive 1000 into 3.44. So it is 777.78. So maximum movement is 777.78 Newton meter. So let so just remember how our mistakes happens in this calculation of shear force diagram and bending moment diagram, and learn from mistakes also. Now start for analysis. New metric, create total length of this beam is 7 plus 1 8 plus 2 10. So 0 to 1 is B support, 0 to 1 and 8. From this node 0 type values and 10. Now this is 1 meter, this is 7 meter, and this is 2 meter. Now give properties, define rectangle, give any properties, assign to view, assign yes, material concrete. This property and material we are now provided only for errorless calculation of this stat pro. So at point B and C there is only roller support. So roller, that means only vertical reaction alone. All others are releases. So Fx, Fz, Mx, My, Fz all are releases. We are doing now only 2D analysis. That's why only Fy. So this Fz is also released. Now shift K for node scene purpose. Use cursor to assign, assign, assign. Now loading, load case details, add, give loading type, live, title is live load, add, load. Member load, concentrated force 200, and this is downward, that means minus, and at a 0 meter distance for that beam. So assign, select this, Assign to selected beam. Assign. Yes. Now next is UDL 180 Newton per meter. This 200 is Newton C, and I type in AdPro kilonewton. 200 divided by 1000 is 0.2. So this is only 0.2 kilonewton meter. Kilonewton only, not. This is meter. Okay, this is minus 0.2 kilonewton and add 0 meter distance. So change. So yes, now it is correct. UDL is also 0.180 kilonewton per meter throughout this beam. Uniform force minus 0.180 kilonewton per meter. Add close. Select values. Assign to view. Right click. Labels. Scale. Apply immediately. And reduce this scale. See this force. Now, yes, this is like this. Now analyze this beam. Run analysis. Save. Now see first deflection. See values of deflection. For that first beam, there is no deflection. This red color portion beam, overhanging beam, no deflection occurs. Now this mid beam, there is, see why, in inches, there is maximum 0.013 inches, and at this overhanging red color portion is also no deflection. So, see here. See 200. See this at 0. Y stat shows 0.01. Here Y. See at see at 0 it is shown. Wait. See at 0 it is shown Fy is 200 negative and our is 200. See this is correct. At 0 it is 200 and at stat see this 0 and this 200 and movement is 0. So movement is also correct. Now next is at 1 meter distance. At 1 meter shear is minus 0.380, so this is correct, and moment is 0.290. See this is positive 0 negative 0.220 and stat is positive, so only Movement sign convention is different in between our manually calculation and StatPro calculation bending moment. Only this is difference. Now next is 0 1. Next calculate for 4.44. See, for 4.44 it is check for this 8 meter distance. No, this, for that select this beam. Now check for 0, 0. Check for 3.44. See 777.78 and here is 778 and here is near 0. Check for 7 0.360 here 360. This is in Newton and stat is in kilonewton. And here is 640. See, this is 640. This moment is 360. Yes, moment is 360. Now consider this. 0 is 360 and 2 is 0. Yes, correct. So our manually calculation and StatPro calculation movements are matches each other. So let's see again deflection shape. See how deflection shape occurs. See, I show you that deflection shape is like this, but here stat show deflection shape is like this. Again it is here it is hugging and at this portion it is no here it is sagging. This is like this hugging like this. See reactions 1 kilonewton 1 kilonewton and our is 1000 newton 1000 newton, that means same. See, this is what is this loads. See beam result maximum bending moment MZ 0.778. Yes, 0.778. This and Fy is 640 here. Displacement is maximum relative displacement is for 2 it is minus 0.013 inches. That means here at 7 meter they are telling 7 meter distance 3.5 meter. That means 7 divided by 2. That means mid of this inches minus 0.013. That means very small. Thank you very much.